Let's now take a look at the reactions of nitriles. Before we look at specific examples, let's go back to the nucleophilic addition of nucleophiles to carbonyl compounds such as a ketone. Generally, in nucleophilic addition reactions, the nucleophile will add to the carbon of a ketone, break the double bond to form an alkoxide or tetrahedral intermediate, and then depending on the reaction conditions, we will either protonate this oxygen with acid, or this nucleophile will push out the oxygen and form an imine or some sort of imine derivative. In the cases of nitriles, we can see, at least initially, a similar reaction where the nucleophile will add to the the carbon of the nitrile, break the triple bond of the nitrile, form an imine ion, and then depending on, again, the exact reaction, we will get different products from this. Nitriles are a diverse functional group that can be hydrolyzed into amides and then carboxylic acids. They can also be reduced using hydrogenation conditions or a hydride reagent such as lithium aluminum hydride and be converted into an amine. Or nitriles can react with a Grignard to form a ketone after hydrolysis of the intermediate. Nitriles can be converted to carboxylic acids under aqueous, acidic, or basic conditions. The reaction goes through an amide intermediate, which is further hydrolyzed to the carboxylic acid. Here's a specific example using this nitrile. If we heat it with water, sodium hydroxide, and then we follow the reaction with aqueous acid, we can obtain a carboxylic acid. We can do the same reaction with sulfuric acid, water, and heat to produce a carboxylic acid. Note that in the basic hydrolysis, because the reaction leads to a carboxylic acid, which is an acidic functional group, we must use a second step where we add aqueous acid to neutralize the base and also to convert the conjugate base of the carboxylic acid into the carboxylic acid. Under acidic conditions, when we do the hydrolysis, there is no need for a second step since the reaction yields the carboxylic acid directly. Nitriles can be converted into amines by using a hydride reagent such as lithium aluminum hydride. As an example, this nitrile here, when treated with lithium aluminum hydride, will be converted into this primary amine. Notice that the amine has the same number of carbons as the nitrile that we started with. So there are 1, 2, 3, 4 carbons in the longest chain, plus a methyl group on the second carbon. In the case of the nitrile, we also have 1, 2, 3, 4 carbons, and there is a methyl group on the second carbon. If we use benzonitrile, we can reduce it into this primary amine as well with lithium aluminum hydride. The reaction starts by lithium aluminum hydride providing a hydride, so an H-, which will add to the carbon of the nitrile, break the double bond, or the triple bond, excuse me. That leads us to this iminium anion intermediate that we see here. This can be further reduced with another equivalent of lithium aluminum hydride to add another hydride to the carbon of the nitrile, what used to be the nitrile, and obtain this oddly looking intermediate with a -2 charge. This will sit around until we finish the reaction and add water or aqueous acid at the end of the reaction to give us the corresponding amine, which in this case is benzoylamine. DIBA is a hydride reagent which we saw earlier this semester, which is used to convert esters into aldehydes. Another use for DIBA is we can convert a nitrile into an aldehyde. Here's an example using this nitrile. If we use DIBA followed by aqueous acid, we can convert it into this aldehyde. Note that the aldehyde has the same number of carbons as the nitrile. So in the case of the nitrile, there are 1, 2, 3, and 4 carbons in the longest chain. And in the aldehyde, there's also 4 carbons in the longest chain. There's also a methyl group in the second carbon in both the reactant and in the product. A byproduct of the reaction will always be ammonia in this reduction. Here's a second example, including the mechanism for the reaction. So benzonitrile, when we treat it with DIBA, it's first going to lead to a coordination between the nitrogen of the nitrile and the aluminum of DIBA. Note that DIBA has 3 groups around the aluminum, so 2 isobutyl groups and a hydrogen. And so it is a good Lewis acid, which can coordinate to the lone pairs on a nitrogen. Once this coordination occurs, or this Lewis acid base reaction occurs, we obtain this intermediate, which has a bond between the nitrogen and the aluminum. It has a formal positive charge on the nitrogen, has a formal negative charge on the aluminum. And this intermediate now has an aluminum that, because of the 4 groups that it has bound to it, the hydrogen on the aluminum is now considered a hydride. So this hydrogen or hydride will add to the carbon of the nitrile, lead to breaking one of the pi bonds in the nitrile, and lead us to this intermediate, which is essentially an imine anion. This intermediate will now be protonated, so the nitrogen here, which really has a negative charge on it, will attack this water or aqueous acid and be protonated and turn into an imine. As we learned earlier this semester, imines, when treated with aqueous acid, will be converted into the corresponding carbonyl, either an aldehyde or a ketone, depending on the structure of the imine. In this case, this imine will be converted into this aldehyde shown here, benzaldehyde, plus ammonia. Nitriles can also be reduced with hydrogenation. So here's an example with a nitrile. If we use a high pressure of hydrogen, so 100 atmosphere of hydrogen, and nickel catalyst, we can reduce this nitrile into the corresponding primary amine. There's a second example here with another nitrile. Again, under the same conditions, we can reduce it to a primary amine. The high pressure hydrogen here can be achieved by doing the reaction in a stainless steel reactor and pumping it with hydrogen gas while the reactants are also present. If we add a Grignard reagent or an organolithium reagent to a nitrile, we can convert them into ketones that have an alkyl group matching the nucleophile. As an example, if we have this nitrile here and add an ethyl Grignard reagent, we can transfer this ethyl group to the carbon of the nitrile, and then the corresponding double bond between carbon and nitrogen will eventually be hydrolyzed into a ketone. There will also be a byproduct of ammonia. Here's a look at another example and the mechanism involved. If we use methyl Grignard, the carbanion here, the methyl group, will add to the carbon of the nitrile, break one of the pi bonds of the nitrile, leading to this imine anion, which will be protonated by aqueous acid to give us initially an imine. And as we learned earlier this semester, imines, whenever we add aqueous acid, can go back to the corresponding carbonyl, usually a ketone or an aldehyde. In this case, this imine will be converted into this ketone plus ammonia as a byproduct. Example, using benzonitrile, if we add ethyl Grignard, the ethyl group will be added to the carbon of the nitrile, and then the nitrile will be initially turned into an imine anion, and then that imine anion will react with aqueous acid to first turn into an imine, which will be then hydrolyzed into this carbonyl shown in the product. The compound shown on this slide, called linomarine, is a compound that is produced by several plants, including cassava, and is used as a way to generate hydrogen cyanide when these plants have the need to defend themselves. So through a reversible reaction we learned earlier this semester, this oxygen can form a carbonyl by eliminating the cyanide group, which eventually will be protonated and produce hydrogen cyanide. In this question, we're going to try to synthesize the following alcohol, starting with this alkyl halide. Note that the alkyl halide has one less carbon, as well as, of course, a different functional group than the alcohol shown as a product. In this transformation, we're converting an alkyl halide into an alcohol, and in the process, we're also adding a CH2 group. Now, you might recall that alcohols will usually, or one way of making alcohols would be by reducing a carboxylic acid. And so if we can somehow add a carboxylic acid from the alkyl halide, we can complete this synthesis. As we learn in this chapter, there are two ways that we can convert an alkyl halide into a carboxylic acid. So one way would be by adding magnesium or lithium to convert this halogen into a metal bond. So we can create a corresponding Grignard reagent, which can then add to CO2, which is dry ice. And then if we add aqueous acid, we can end up with a carboxylic acid shown here. We can do a similar reaction by using sodium cyanide to do an SN2 reaction on this alkyl halide and add a nitrile group. And then if we hydrolyze that nitrile group, either under acidic condition as shown here, or under basic conditions, we can convert it into a carboxylic acid. If we then reduce this carboxylic acid with lithium aluminum hydride, we can obtain the corresponding alcohol. Notice the alcohol will have the same number of carbons as the carboxylic acid. The carbon that we added, or the extra carbon we added in this carboxylic acid, will come from either CO2 or from the cyanide nucleophile. In this question, we want to make the following ketone from a nitrile. One of the reactions that we learned about in this chapter is that we can take a nitrile and add a Grignard reagent to convert it into a ketone. The Grignard reagent will generally add an alkyl group to the carbon of the nitrile. And so in this case, we're adding an ethyl group. And then we will initially obtain a nitrogen double bond. So the nitrile here will be converted into an imine anion. This carbon will have an ethyl group from the Grignard reagent, and it will have an ethyl group from the nitrile that we started with. So here's an ethyl group, so that could be that one. And then we could add an ethyl group from the Grignard reagent. That anion here will be protonated by water in the last step of the reaction, and then the resulting imine will be eventually hydrolyzed into this ketone.